Hey, welcome back, FMT100. We are in Unit 2. This is Section 3 and Power Tools. So, awesome. Here we go. Here we go. No matter what we are using, we tend to have most of our power tools electrically powered, whether it's corded or battery operated. Uh, we have to keep the general electrical equipment safety in mind. Using the tool in a wet place may open us up to potential electrical problems. We need to be aware of that. If the tool is corded, meaning it has a power cord that we plug in, we're going to want to make sure that the cord stays away from any cutting blades, pinch points, rotating pieces of equipment, or the shaft. Pick wherever that electrical cord would get tangled up, damaged, whatever. We're going to make sure the cord does not get into those areas. That is something we're always going to have to keep an eye on while we are using the tool. For proper protective equipment, eye protection. No matter what the tool is, eye protection's on. Properly worn. If we were on campus and in the lab space, I would be harping on you. Once you hit the lab floor, eye protection goes on. If you were in a plant facility, once you're in the plant space, on the plant floor, the manufacturing floor, shop floor, eyewear goes on. And even if you're not, let's say you're at a remote site, once you start working at a task on hand, whatever it may be, eyewear goes on. All right? Eyes are sensitive. You only get two, not two shots. You only have two, so let's keep them together. Stereo vision is awesome. That said, hand protection is something else that we're going to definitely want to keep in the forefront of our mind, and at least hand protection either on, wearing it, or nearby. All the power tools that we use tend to leave sharp edges behind and or sharp edges themselves. So we want to be able to protect our hands the best we can from the oopsie sharp piece of metal that just really wants to take a bite out of us and get a taste of that human blood that it so desperately needs. Everybody may chuckle and think I'm weird for saying that. I'm telling you now, metal has the taste for human blood. I don't care what metal it is. It's got a taste for human blood. It likes it. So I always try and make sure I don't donate too much to my projects, and I wear my hand protection, typically leather gloves, whenever I'm operating any tool. The only tool I won't wear a glove on while I'm using it is a drill. But once the drill goes off, the glove goes on. I know that sounds stupid and anal, but once again, even a drill, as we're drilling a hole, there are sharp edges left behind, and some of the shavings are also very, very sharp. So I'd much rather protect my hands. So while we're protecting our hands, let's also protect us from a messed up tool. So we're going to inspect the tool before and after use. So what we're looking for is we're going to check out the housing or casing, and we're going to make sure that there's no cracks, there's no pieces missing. We don't want anything that would jeopardize the integrity, the structural ability of that tool to remain a tool. And we don't want it to literally fall apart as we're using it, exposing the innards, whether it's electrical or the gearing, that we may get injured from. So we're going to inspect before and after use, as perhaps while using the tool, tool's old and it's finally just seen better days and it's finally cracked, or something was damaged just due to a fluke. You never know. All right. So before and after. Yes, it may mean that essentially we are checking the tool twice. And what's the problem with that? There is none. And that's the good news, okay? So I know it sounds goofy and perhaps even a little, neurotic, but inspecting a tool is well worth the time and effort that goes into it. That means you've got a serviceable tool and it's a safe tool to use. Speaking about tools that we use, portable drills, you will use a lot. I honestly do think it's perhaps one of the most frequently used tools. I know on the farm, we use drills about every project we have, whether it's a regular drill or even an impact drill or impact driver. So all over the place. Now, we used to use AC tools, AC drills, but we have now moved up to the world and we're actually using more the cordless or the battery operated ones. So the AC, they usually had a keyed chuck. No, even today though, that keyed chuck is becoming uh, less and less frequent. You always lose the damn key, no matter how well you try and attach it to the extension cord, or I'm sorry, the cord. Um, it's just a pain. Typically, the stationary drills will still have a keyed chuck, but for a lot of the portable AC drills, they're now going away from the key. They're going away from the keyed chuck and going for a keyless chuck. Right now, just about all of the drills that are cordless, battery operated, are keyless. They figure that you're moving from point A to point B all over the place, and let's face it, music, you're going to lose the damn thing. And there's nothing worse than losing a key for your drill. There are field expedient ways of tightening a keyed chuck without a key, and I am not going to discuss those because I don't want you to get any ideas. The other type of drill out there is a hammer drill. Now, hammer drills are typically AC powered because you need that oomph, you need that power in order for the hammer drill to work effectively. And there are different styles of them. I have one example. It's decent and it gets the job done here. And they go from relatively small, about the size of a regular AC variable speed drill, to holy crud, it's like you need to be Conan to hold this damn thing. And it has two massive handles that you need to hold it and keep it under control. So there are some huge drills out there, which I need to go over real quick. So the way they look at drills is not only the amount of torque that they have, but also the chuck size. So most chucks usually use a 3/8 inch chuck, so it'll take a 3/8 inch size shank inside the chuck. And the larger drills, both AC and even the DC ones, can go up to a 1/2 inch. So the larger the chuck, think of the more power this thing has, which also means the more damage it will do to you if it gets bound up. So little things to keep in the back of your head, all right? Portabands, or as they're saying, portable bandsaws. They're known as portabands. You call them a portable bandsaw, and somebody's going to think you're you're being uppity. Just call it a portaband and you'll fit right in. So, unlike their stationary brothers, which are known as just bandsaws, portabands are used to cut material in the field because they're really mobile. Most of the decent portabands are still corded, so they're AC powered, but some of the smaller ones are battery operated. They're cordless. So that's nice if it's small material, like conduit, all the way up to, I'd say, 1.5 inch conduit, whether it's rigid or EMT. So either thick-walled or thin-walled conduit, which is piping, copper pipe, PVC pipe, strut. Some of the thinner material, yeah, battery operated, way to go. You can get a lot done with them. But for anything larger, like thick steel or thick material, you can still use a portaband, but you're going to use the AC powered ones to do it. So portabands get their magic, if you want to call it that, from basically having a hacksaw blade that's in a loop. So it's always cutting in the same direction. You don't have to do back and forth. It's just this loop that's always cutting through. And if you've got a good blade on and nobody's like pushed on it or tried to feed the portaband through the material real fast, all you have to do is you let the weight of the portaband work its magic, and the portaband will do the cutting for you. All you're going to do is you're going to guide it. That's it. Let the weight of the bandsaw do the work. All right. Once again, we're still going to be using protective eye equipment, as well as you are going to be with a cutting material. Yeah, you're going to want gloves. I promise that. On the other side of the spectrum, we've got reciprocating saws. And reciprocating just means it moves back and forth. So it kind of mimics the same movement that we're familiar with sawing, except it gets to do it on an industrial scale. No pun intended on that. And they're really nice. Most people don't call them reciprocating saws. They'll usually call them by other names. If it's a reciprocating saw that uses a thin blade that is used to make cuts, really tight curving cuts, that's usually a scroll saw or a skill saw. And 9 times out of 10 people will ask for a skill saw. Skill saw happens to be just a brand name from Skillcraft, and that's it. So that's if you want nice tight curves, skill saw is the way to go. If you're just looking at demo cuts, you're just trying to cut through material because you're ripping it out and you need to just do rough cuts, Sawzall. So that is a larger reciprocating saw. It uses a wider blade, and it's used primarily for demo. It's a skill saw, not a skill saw, it's a Sawzall, because it's made from the big one. The Sawzall that first came out was from Milwaukee tools, and it was a Sawzall, and that name just kind of stuck with it. So now it's anything that is a large reciprocating saw is a skill saw. And yes, I will have demos for that one as well, and both corded and battery operated, so you get both bangs with reciprocating saws. Keep in mind, you can get different blades for both these to cut through various materials. You can do a lot of soft materials, woods, plastics. The list kind of goes on all the way up to soft metals. If you want to do any of the harder metals, then it has to be very thin. But both the skill saw and the Sawzall will cut through that material as well. Right angle grinders. So these are fun. A lot of use out of them. They're primarily used for grinding, though. You can get different discs for them, and there's different type of grinding discs as well. So you can do discs that are great for when you're trying to shape and move a lot of hard metal. You got different discs for moving soft metal. You've got discs for polishing, sanding. The list just kind of goes on. So there's a disc for each application. There's also cutoff discs, so you can use it to cut off the head of that bolt that's giving you nothing but static, or that screw, or cut through some thin stock. So right angle grinders, very versatile, and corded and battery operated. All right, now most of the corded ones, you have a choice of disc sizes. It's either 4.5 inch or 7 inch, and that's the diameter of a brand new disc. The bigger the disc, the faster that outer edge is moving, and that could be a problem. So with angle grinders, we're always going to check out that disc before we use it to make sure the disc is not damaged, the disc is not cracked, there's no big chunkies missing, it's not worn unevenly, so it's unbalanced. If you've got any of those conditions with your disc, you throw the disc away and get a new one. because if not, the chances of that disc failing catastrophically is greatly increased, and there's nothing worse than having a disc basically blow up. It is rather unnerving, uh, and you thank the days that you're wearing all the protective equipment when that happens. There is a particular protective piece of equipment that you're going to want to think about when you pick up an angle grinder, and that is a face shield. So the face shield is really nice. You're going to wear that in addition to any eye protection you're wearing. And what the face shield does is it protects your entire face and part of your neck. So that's great because angle grinders throw off a ton of sparks and metal dust and debris. And if the disc fails, it throws that out as well. And the face shield helps protect against all that. This is one of the few rotating pieces of equipment that I would also wear gloves on. Now, the gloves are not going to protect you from the disc itself, but it will protect you from the sparks and heat generated from using this piece of equipment. Just to let you know. And, of course, I'll have examples for you as well in the lab. Last but not least, the circular saw. I love this one. It says used mostly by carpenters or woodworkers. Well, yes, that's true. My carpentry friends and cabinet makers make great use of circular saws. We're facilities, so we get to be a jack of all trades, and we too get to use circular saws. What's nice, they're portable. They do roughly the same task as a table saw, except instead of moving the material to the table saw, we move the saw to the material, which is kind of nice. Much like a table saw, we need to make sure that our material is properly supported, both the piece that is being cut off and the piece that is not being cut. So those two halves need to be properly supported through the entire cut. We also need to make sure that we're using the proper blade for the material we are cutting and make sure the depth is properly set. All right. And once again, this is going to be one of those areas where we have to keep an eye on the cord for the saw and any extension cord we may be using, just because they tend to get in the way. So always think that the cord is trying to kill itself, and we got to make sure we protect the cord. And yes, primarily it's used to cut wood, but you can also use it to cut thin metal if you use the proper blade. Now, as a spoiler alert, there are two general types of circular saws. We have our regular everyday circular saw, and we also have a worm gear saw. And in lab, I will show you what they look like. One's really nice for some cuts, and the other one's a great general purpose one. We'll discuss which one's which in lab. In the meantime, that's the end of section 3 for the lecture, which is awesome. All right, so finish this one up. We'll get to the lab, and we'll finish off this unit. It's a real quick one, and that's what I like to see. Catch you on the flip side.